When talking about the sovereign of the Cretaceous period, the Tyrannosaurus rex is usually the first dinosaur that comes to mind, as it possessed a variety of formidable weapons and features that made it stand out as an almost unbeatable force in its region of origin, North America. However, the T-Rex was by no means the only large theropod existing at the end of the Cretaceous. In fact, just 30 million years before that period, a trip to South America would put you face to face with an equally fierce theropod and nearly as imposing as the T-Rex, the Giganotosaurus. Before we dive into the subject, please leave a like, share this video with your friends to help our prehistoric community grow, and subscribe to the channel if you haven't already done so. Now, without further ado, let's get to the video. In the region of Argentine Patagonia, various types of dinosaurs have been discovered, among which the immense sauropods stand out, such as the Argentinosaurus and the Patagonodon, currently considered some of the largest sauropods ever found. However, these lands were also home to gigantic and terrifying predators, most notably one of the largest carnivores of all time, the Giganotosaurus. The name Giganotosaurus originates from ancient Greek, meaning giant southern lizard, or referring to its impressive size. We will talk more about this point shortly. Its first remains were discovered in the province of New Cane in 1993 by Reuben D. Carolini, an enthusiastic fossil hunter. Interestingly, 70% of the holotype specimen was found among the fossils, including a partial skull, a large part of the vertebral column, femurs, and the tibia, to name a few elements. In 1995, Argentine paleontologist Coria and Salgado formally named and described the species as Giganotosaurus carolinii, in honor of Reuben Carolini, the discoverer of the first remains of Giganotosaurus. In 1998, Coria and Salgado attributed a partial lower tooth to the genus Giganotosaurus, realizing it was 8% larger than the tooth found in the holotype specimen. This discovery led to revised estimates of size, but currently, it is not known for certain whether this specimen was indeed larger than the previous holotype or if it was the same size, just with a slightly more robust jaw. The Giganotosaurus lived during the late Cretaceous period, approximately between 98 and 97 million years ago, in what is now Argentine Patagonia. This carnivorous dinosaur was one of the largest of all time, although over the years its size estimates have varied due to the scarcity of known specimens. In earlier times, some estimates suggested it could reach up to 14 meters in length, but current estimates suggest it was between 12 and 13 meters long, stood 4 meters tall, and weighed between 7 and 8 tons approximately. The Giganotosaurus was part of the Carcharodontosaurid family, and it is noteworthy that this family has its roots in the allosaurs of the Jurassic. Most of these large Carcharodontosaurids lived in the southern hemisphere, specifically in Africa and South America. The closest relatives of the Giganotosaurus include the Mapusaurus and Pteranodon from South America and the Carcharodontosaurus from North Africa. If you are interested in learning more about the Carcharodontosaurs or the largest in the family, leave your comment and I will soon be bringing this video to the channel. Let's now address one of the main features of the Giganotosaurus, which is its enormous skull. Unfortunately, we do not possess a complete skull of this genus, but based on the known parts and comparing with what is known of other Carcharodontosaurids, the skull size is estimated to exceed 1.60 meters. Notably, for the size of the Giganotosaurus, its skull was proportionally larger than the rest of its body. The nasal bone of the Giganotosaurus, like that of all Carcharodontosaurids, had a rough texture covering the entire top of the bone. Additionally, it had a small crest at the top end of the lacrimal bone, pointing upwards and tilted backwards. This feature dates back to its predecessors, the allosaurs, although in allosaurs, these crests were more prominent. When analyzing the skulls of Carcharodontosaurids, especially the larger ones from the southern hemisphere like Giganotosaurus, the nasal bone stands out as notably more textured compared to other members of this family. Moreover, the skull of the Giganotosaurus was notably more robust and large when compared to its relatives, though it was not as wide as that of the Tyrannosaurus. Not only was the skull of the Tyrannosaurus wider than that of the Giganotosaurus, but in general, Carcharodontosaurids did not exhibit as robust a build as that present in Tyrannosaurus. This is especially evident in the pectoral girdle of the Giganotosaurus, which was proportionally shorter than that of the Tyrannosaurus. The estimated bite force for the Giganotosaurus is approximately 1.5 tons, which is less than the estimate for Tyrannosaurus. Despite the large size of the Giganotosaurus's head, both its teeth and jaws could not support as much force, as they were not adapted to the stress that this could generate. These characteristics are not unique to Giganotosaurus, also applying to its relatives, the Carcharodontosaurids, and its predecessors, the Allosaurs. The function of the upper jaw was to capture and hold prey, while the lower jaw was designed to make deep cuts with curved, serrated teeth, idealized for tearing flesh and causing significant cuts in prey. The way Giganotosaurus likely hunted involved capturing and knocking down its prey with fast and powerful bites, taking advantage of its ability to move the skull to the sides thanks to the vertebrae in its neck. This would be of great assistance during hunting. Potential prey for Giganotosaurus included ornithopods and juvenile sauropods. The neck of the Giganotosaurus was notably robust and strong, necessary to support the weight of its enormous head. As mentioned earlier, thanks to the vertebrae in its neck, the Giganotosaurus had good mobility, allowing it to move its head from side to side. Like all large carnivores, the Giganotosaurus had relatively small arms in comparison to its body, with hands ending in 3 fingers. The vertebrae of its tail featured elongated neural spines, which extended from front to back, being robust in the center. However, with Giganotosaurus, the focus is not solely on its large size. Several interesting studies have been conducted, exploring aspects such as its locomotion and thermoregulation. We will discuss these points next. Studies have been conducted to determine the speed at which certain large theropods, including Giganotosaurus, could achieve. In a 2001 study by physicist Ernesto Blanco and Mazzetta, it was estimated that Giganotosaurus could reach a maximum speed of 50 kilometers per hour. However, this value was later adjusted to approximately 33 kilometers per hour, as mentioned in the book Dinosaur Theropods, Records and Curiosities. It is important to note that these estimates are under ideal conditions and not for long distances, since Blanco and Mazzetta suggested that the imbalance caused by increased speed would be a limiting factor. In 2017, a study on the biomechanics of the Tyrannosaurus was published, revealing that the skeletal loads were excessively high to allow adults to run at high speeds. Previously, it was believed that their relatively long limbs indicated a good running capability, but it seems that these same features would have limited them to walking or a kind of fast-paced stroll only. The study mentions that this limitation does not apply solely to Tyrannosaurus, but also to large carnivores such as Mapusaurus, Carcharodontosaurus, and evidently, Giganotosaurus. Estimating the speed of these animals is complicated due to various factors. First, there is the structure of their bodies. We can get an idea by looking at their closest living relatives, birds and crocodiles, but there is currently no animal with a long tail and hind legs positioned beneath the body to give us a more precise understanding of the locomotion of these dinosaurs. Another factor is weight. In 1999, paleontologist Rhys Barrick and geologist William Showers found very similar oxygen isotope patterns in the bones of Giganotosaurus and Tyrannosaurus. These patterns of thermoregulation indicate that they possessed an intermediate metabolism between mammals and reptiles, meaning they were homeothermic, maintaining a stable central body temperature. This would have contributed to the rapid growth of Giganotosaurus. Studies related to the brain of Giganotosaurus have revealed that it had large olfactory lobes, indicating a greater dependence on smell than vision, since the optic lobes were not as developed. Over the years, there have been debates about whether large carnivores such as Giganotosaurus, Mapusaurus, and Tyrannosaurus could live in herds or form small social groups. The discovery of several specimens of Mapusaurus of different ages suggests the possibility of small social groups or herds of these dinosaurs. Although this observation occurred due to a catastrophic event that gathered the specimens in the same place, it points to the existence of dinosaurs that perhaps formed small social groups, which would be beneficial for hunting large sauropods. The Giganotosaurus coexisted with various groups of dinosaurs, including titanosaur sauropods such as Andosaurus and Rebbachisauridae, which were the largest herbivores in their habitat. Moreover, it shared the environment with ornithopods and other theropods, such as Alvarezsauroidea alnichetri, Dromaeosauridae bichiraptor, and Abelisauridae acrixonatosaurus, clearly indicating that the Giganotosaurus was the dominant superpredator of its time. Although we often associate Giganotosaurus with Argentinosaurus, thanks to documentaries like A Land of Giants or The Giants of Patagonia, these two giants in reality never coexisted. Giganotosaurus is older than Argentinosaurus. The predator that lived alongside this enormous sauropod was Mapusaurus, as depicted in visual representations. Giganotosaurus is widely recognized in popular culture, being one of the largest carnivorous dinosaurs. Replicas of its fossils are present in various museums around the world. and scale figures of this predator can be found in different contexts, from video games to books on dinosaurs. It has also been featured in documentaries such as A Land of Giants, was special from A Walking with Dinosaurs, and the TV series of Primeval. On the big screen, Giganotosaurus made its appearance in A Journey to the Center of the Earth and in the film Jurassic World: Dominion. Well, folks, that's the end of the video. If you liked it, please leave a like. If I forgot to mention something about Giganotosaurus, or if you would like me to cover a specific topic, please comment. Share this video so that the prehistoric community keeps growing. If you haven't subscribed yet, do so. It's completely free, and hit the bell to receive notifications whenever I post a new video. Without further ado, I say goodbye to you. Until next time.